All right, hi everyone. We are back and we're going to actually start to put together our strain gauge. So this is the cantilever beam that we're working with. So I'm going to kind of carefully show and unhinge this, that it is has two sides. So this is the top surface. So you have a red wire and a black wire connected to the strain gauge. Our half tone bridge configuration, there's a side in the back. There's a white wire and that black wire is connected. So the black wire connects, just like on the diagram you see in the lab handout, the black wire connects the top two strain gauges. And we are going to basically build around that. So we have a black wire connected to the top and bottom. We have that red wire that's only connected to the top strain gauge. And we have the white wire that is only connected to the bottom strain gauge. And from this, we are going to kind of build our Wheatstone bridge circuit that we've seen previously. So what else am I going to need? Well, I'm going to need two resistors that are the strain resistance as my strain gauges, because I want a Wheatstone bridge that's at balance. Now you'll notice when we actually take it to the experiment, it's not going to be at balance. Why is that? Well, because I was nice enough to put the strain gauge on for you, so you don't have to do it yourself, but I was not nice enough to pre-strain the strain gauge and basically deform the material. So we're not going to be at balance as we kind of talked about in theory, but we'll deal with that in its own time. So we have our two resistors. We are going to have our breadboard here. We are going to also have our, basically to power our kind of Wheatstone bridge circuit. We are going to also have our power amplifier, which we're going to have to plug into in order to measure what the output voltage is. And notice it's at plus or minus 20 millivolts. Very, very important that you do so for this experiment. And then finally, we're going to have these two wires that are going to connect red and black to our terminals. So I'm going to start off, because as I've told you many times in this class, I did not take circuits. I had to learn circuits the hard way by getting shocked and fixing things around the house. But I'm going to go ahead and do the simplest part first, which is attach those red wires to these terminals. So I have my kind of external red wire, and I'm just going to plug it in right here, and I'm just going to tighten, as you've seen me do it previously from the thermocouple lab. Not the most exciting part of this lab, but still exciting nonetheless, to me at least, and to you. So remember, write an excellent lab report on this. So I'm going to go ahead and loosen this guy. I'm just going to thread the needle. As I say that, more difficult than it appears. I'm winding. Unfortunately, I can't capture that excitement. And I'm finally through. So, see that here. Tighten, tighten, tighten. There we go. First part of my bridge taken away. So I'm going to go ahead and move this to the side. So I'm also going to move this over here because it's not really exciting now at this point. But here we get to kind of the nuts and bolts of it, which is our breadboard. So I'm going to go ahead and move this to the side. Put this over here. It's not easy. My phone is actually just balancing on this. That's how I do these videos, all by myself. So this is basically our input, our excitation voltage. It's going to power our Wheatstone bridge. So I'm going to go ahead and I'm just going to put it right here at the 10. So I'm just going to click it into place. Again, I'm sure that circuits people are frowning. So you can see that I have what's of interest to us, the 5-volt excitation, and then the ground, the GND. So what we're going to do, actually I'm going to zoom in here. Ooh, Professor Steimel's getting very fancy. So now I'm going to go ahead and put this kind of circuit together. So reading from my chart, and I have it kind of on the left, so the top strain gauge wire, that red one that we talked about and saw previously, that needs to go and plug into the 5-volt. And the 5-volt is on the 13. So I'm going to go ahead and plug it in on the 13. Excellent. Now, the wire that's going to connect to my ground is going to be on the bottom of the strain gauge, that lone wire. That was that white wire. So I'm going to go ahead and do the same thing. I'm going to take, where's my ground? It looks like it's at 10. So I'm going to go ahead and plug that in right there. Bravo, Josh. Professor Snow. The next thing I have to do is I'm going to have to place my two resistors. And my two resistors, one of them has to touch the 5-volt and one of them has to touch the ground wire. So I'm going to have one of them touching the 5 volts, so just right here in the 13 slot. I'm just going to leave them hanging for a second. And then I have one that's going to connect to the 10 slot. Great. Now, what's going to connect to that is going to be the wire that goes to your positive terminal. So, I'm going to go ahead, my red wire that I'm bringing in from the other side. So not my red wire from the strain gauge, but the red wire from my power amplifier. So I'm going to go put that right here, and I'm going to put both of them, they're kind of sitting at that 21 spot. I'm going to go ahead and solidify that. They're going to sit forever now at 21. Not a sponsor, but appreciated. Actually, I'm going to go ahead. Nope, not a sponsor anymore. They're at 20. So, and actually, I'm going to go ahead and switch it again. 19. Because one of them is a little bit, has to stretch a little bit more. There we go. You could see now I was a material scientist and not an electrical. So there we go. And then finally, we need to connect this red wire here, which I was talking about. So the red wire right here. So not finally, but almost finally. Red wire is now connected. And then finally, I'm going to connect my black wire to the black wire of the other strain gauge. So that black wire from my power amplifier on my left hand here, and my black wire from my this is the black wire from our strain gauges. So I'm going to connect this and our black terminal here. So I'm going to go ahead. I'm going to just put an arbitrary place here and here. 24. Oh, I missed the opportunity for Forever 21 sponsorship. There we go. So let's go ahead and take a look at this setup. There it is in all its glory. I'm going to go ahead and zoom out, and you can show the full picture here. So there it is, all of it in its glory. So let's go take it and let's run an experiment. I'll see you in a bit. So we've got our beautiful cantilever beam strain gauge setup, the half Wheatstone bridge configuration with our strain gauges right there. I was nice enough to already pre-apply them on both sides. We went through our half Wheatstone bridge circuit. We've got it now plugged in, set at plus or minus 20 millivolts, and now we're connected to the DAC. So let's go ahead and see if it works, or let's see if I failed miserably. So we're gonna go ahead and put our waveform chart on here. We are going to do our while loop right here, just like we've done in previous videos. We are gonna do our Boolean operator as such. We are going to also create a stop. Where's our Boolean stop button right here? We're also going to go ahead and now put our vernier sensor DAC, that's pretty important, on here. It's gonna think. You know the procedure at this point. Thinking. Here we go. And let's go ahead and set timing. Good right here. And let's go ahead. We need to make sure that our probes are plugged in. So let's go ahead and replug these guys in. And we have our probes. So let's go ahead and plus or minus 20 millivolts. So now we can go ahead and start to run our experiment. So I'm going to go ahead and start to connect. So actually, let's go ahead. Let's click on this guy one more time. It needs to think. Right here, and so let's go ahead and wire it here to here. Let's stop here. Let's stop here. We could save, but I just want to kind of visualize this for a second. So right now, we're just going to kind of touch the end. So look, if I go a little bit further, you see it starts to bend. So I want it just touching. So just touching. Again, on this micrometer, if you go kind of these these numbers 1, 2, 3, 4, 5 are tenths of an inch. Excuse me. So let's go ahead and press play. We can kind of see a value here. Actually, sorry, I want to be at. I was actually at plus or minus 200 millivolts, so that was not right. So let's go ahead and do one more time. Actually, let's make sure that our See, you have to do a little bit of live demos. On my way back, I switched it accidentally. That's looking much better. Okay, so why is it not 0? Well, why is my there's no strain on it. Well, it's because, again, my material was pre-strained due to my dumb thumbs. So that's why we're not at our exact balance equation, even though we have the same resistances. So that's that value. I'm going to go ahead and now strain my material. Not the exact values, but just to kind of show you the difference. So let's go ahead and click and play. And you see a big jump, as you might expect from our excellent, if I may say so myself, our Wheatstone bridge results. So that's it. You're going to do that for 0, 0.1, and 0.2 deflections. You're going to calculate experimental strain, that voltage. You're going to correlate it to what is the strain value, and then you're going to compare that to the theoretical value. So congratulations. That is the last lab for ENGR110. Write an excellent lab report, and I hope to see you in a future class, Mech 202, or who knows what I might be teaching in the future. So I will look forward to seeing you then. Thank you so much for a great semester, and let me know if you ever need anything. Thanks. Bye.